We studied the cosmic linear anisotropy solving system class with the aim of adding a two-field inflation solving feature. We focus on the case of double inflation with canonical kinetic terms. The purpose of this is being able to use class numerical solutions in a more complicated two-field model with a non-canonical kinetic term coming from a higher derivative theory. Class simulates the evolution of linear perturbations in the universe. It also computes background and thermodynamics quantities, as well as the CMB. To do so, this tool has several modules, each of one computes the quantities needed for the following modules to work, like here. Now, inflation is an early period of exponential expansion of the universe. It successfully explains the flatness and horizon problems. It also provides a mechanism for the generation and evolution of density perturbations that give shape to the universe we observe today. The model in charge of inflation is primordial.c, which computes the primordial spectra. To do so, there are several ways. It can receive the amplitudes, tilts, and running for a simple analytic form. The other option is to numerically compute the primordial spectra. For this, class has two ways: to receive the shape of the potential B for the inflaton field, or to receive the Hubble parameter in terms of the inflaton field. The main physical equations class deals with in this module are the background equations and the evolution of the perturbations. The latter is in terms of the Mukhanov variable in the Fourier space. In this process, the tasks are divided in a variety of functions. The main function is solve inflation. Here all the other internal functions are executed. The most important is evolve background, which evolves background quantities through its equations numerically using a potent and flexible integrator that is invoked all throughout the code. This integrator receives a vector with an initial value of the quantities it is going to integrate, and it also receives a function that tells it how to compute the derivatives of these quantities. The function doing this in the primordial module is primordial inflation derivatives. Here the background and perturbation equations are coded. Another important function is primordial inflation spectra. Here the background plus perturbation equations are integrated in order to compute the primordial spectra for each wave number k. Here, these equations are integrated until the wave number k is much greater than the value of the Hubble parameter h times the scale factor a, and the variation of the curvature with respect to time is stabilized. In our case, in our model, the background equations are very similar but with an extra field, and the perturbations are analogous for each field. The modifications that we started to implement will allow class to numerically compute the primordial spectra for a two-field model with canonical kinetic terms. First, more parameters describing either the potential B or the Hubble parameter h will be stored, requiring an array instead of single variables. As we aim to make these modifications more general to multi-field models, we added a new integer variable for the number of fields. This variable will determine the size of the array containing the parameters to describe the energy. Then we need to expand the number of quantities, so we will replace the variable indexing phi, which is an integer that indicates the index of the inflaton field in the vector of quantities, for two new integer variables, indexing first phi and indexing last phi, that will indicate the interval of integers that index the several fields. We proceed to modify the functions that receive the inflaton field as an argument, so they can instead receive a vector with the several fields. This is needed mainly to compute the potential B at a given set of values for the fields. The function findAttractor, which sets the initial conditions for the inflaton field at the attractor solution, will be skipped, considering that in multi-field inflation there is not only one possible trajectory in the field space, so that an attractor solution is not well defined. Due to this, we are still looking for other options, such as an stochastic choice of initial conditions, resulting in a spread of the primordial spectrum. We wish with these modifications to open the possibilities for class to work with a broader set of inflation scenarios, and eventually allow for models with non-canonical kinetic terms to be worked with.